I've received several questions over the years about how I lay out my segmented turnings. So I thought for this project, which is a Greek vase called a lekythos, that I would show how I laid it out, determine the size of the rings, and do all that stuff. I pretty much do a manual process when I lay mine out. There's probably as many ways of doing it as there is segmented turners, and this is just my way. It's not the right way. It's not the wrong way. It gets the job done for me. Like I say in the video, these turnings or these layout of these things are pretty much the ideal project for a spreadsheet. So if you like to use a spreadsheet, you can certainly do that. And there's also programs out there that you can purchase that'll lay it out, give you all the dimensions and all the segment lengths and widths and all the other stuff that you need. But let me go ahead and show you in this video how I laid out my lekythos. For this project, I went on the internet and I Googled the name of the vessel we're making, the lekythos. And then I found this piece of clip art. So I printed it out, and it's not exactly the height that I wanted. It's about 8 inches, I think. And I wanted it to be bigger than that. So what I did was I divided it into 10 equal segments. So I got 10 squares going, 10 rows going this way, and 4 columns going this way that are all the same size. So now that I have that on there, I can go ahead and transfer that to another piece of paper to be the size that I want. When I first drew it out, I drew it to be 12 inches tall. So what you do is I made a line at the bottom, 12 inches up, and then I divided that space into 10 pieces and 2 going this way. So all these squares are the same size. So I could take the previous picture and then just plot out the points going up till I got the shape reproduced. After I did it, I thought that that was a little bit too tall, so I decided to make it a different size. So I went back to the drawing board and I decided to make it 10 inches tall. And based on my research and the pieces that I've seen that were from ancient Greece, a lot of them were like 25 and a half centimeters, which is about 10 inches tall. So I figured, well, okay, that's pretty good size. So this one's 10 inches, so this graph paper is 1 inch square, so I just drew 10 down, and then did the same thing, plotted out the thing from the original drawing until I got it the way I wanted it, and tweaked it a little bit to get the shape. Though these bottom pieces, this piece and this piece, I'm making sure that's showing up there, this piece and this piece are going to be solid ebony, so there's not going to be any segmented piece on that. And this little top piece right here is going to also be a solid ebony. This part in the center is going, I've drawn some lines over, but this part in the center is going to be the feature ring. And then we're going to have a piece of holly, then an ebony ring to separate the rest from the rest of the vessel. And the rest of the vessel is going to be made out of cherry. So we need to know the diameter of the piece so that we can do the calculation on the segment widths and lengths and whatnot. So first thing you have to do is actually make the feature ring. So that's what I did here. You see that shows up there. So I made the feature ring, which is a Greek key, and that's going to be, once I made that, I could figure out the diameter, and that's going to be the largest diameter of the feature ring, which is right here. So measuring that, it turned out to be 4 inches. So at the moment, I'm not quite exactly at 4 inches. When I look at it, 2 inches would be half would be the radius, so that'd be out here someplace. So what I need to do then is I need to move my center line, which is here. I need to move this center line over to here, and then that'll be what we'll use for the calculating the rest of the rings. So really, when you're doing one with a feature ring, you really need to make the feature ring first to determine what it's the final final diameter is going to be, and then that sets everything else after that. So what I'm going to do is I'm going to erase all these lines that are on here, and then we're going to go ahead and start laying out the segments now that we know the diameter. And I'll move this center line over to here. So let me finish that, and then we'll come back and show how we lay out the rest of the pieces. I've cleaned up the drawing. I got rid of all the lines we didn't need. I drew a new center line, which is this, the thick line going down through here. It's 2 inches over from the top edge of this feature ring, which would make it a 4-inch diameter. I've sketched in the approximate thickness of the wall. It's a little thicker. This piece will probably be more like 1/4 of an inch, but I just kind of sketched in 3/8 of an inch. I'd rather leave myself a little extra than not. I've drawn some lines over here. I like to do all my calculations on the drawing. These things are, tailor-made for a spreadsheet. So if you're like to use Excel or any of the other spreadsheets, it's just a matter of multiplying the diameter times pi and divided by the number of segments, get the segment length. So it's really designed for a spreadsheet. In fact, there's some programs out there that'll do all that math for you, but I don't know. I kind of like to do it myself with a calculator, so it makes me feel like I've accomplished something, I guess. So first row here I have is the ring number, then the diameter, the segment length, the board length, the segment width, the segment thickness, and then the material I'm going to use for the segment that I've drawn in here. This is the feature ring, so I've already done that. So what we need to know is from the bottom of this little piece of ebony ring here to the top of this ebony piece down here, how many segments, how many rings can we get in there? Generally, I start with a 3/4 inch thickness of the ring. So if we put that on there and use a 3/4 inch scale, is just a little over 6. So there'd be 6 3/4 inch pieces in there. But it is a little bit over 6 inches, or 6 segments. So what I'm going to do is to divide this up. I'm going to put the 0 on the. Let me move over here. I want to put the 0 on the line that represents the bottom of that ebony ring, and I'm going to put the 6 out here on the line that represents the top of the ebony pieces at the bottom. And I'm just going to go ahead and mark off 1-inch increments. So that'll give 1, 2, 3, 4, 5, 6 pieces that are going to be just a little over 3/4 of an inch. Truthfully, it probably wouldn't make that much difference, but we're going to go ahead and do it that way anyway. If I go back to the 3/4 inch scale and I measure from the bottom of this piece here to the top of this ebony ring, I can see that it takes a little over 3/4 inch pieces to fit in there. So what I'm going to do is divide that by 3. So I'll do the same thing. I'll put the 0 on the top line here. I'll put the 3 on the bottom or the top of that ebony line, and then I'll just mark off 1, 2. So I got 1, 2, 3, and there'll be a little over a 3/4 of an inch. So, all right, let me draw these lines in here, and then we'll start marking off the segments. All right, I've divided the vessel up into the number of rings. There's 6 at the bottom and then 3 at the top, not counting the feature ring and the ebony and holly ring there in the middle. Now what we're going to do is start laying out the segments. So let's just pick one here in the middle, for example. These go pretty much straight up and down, so it's really not much of a challenge on that one. So what I do is I need to know how far to come over or determine, I need to decide how far to come over. It could be 1/4 of an inch, could be 3/8. If you know, it really is up to you how wide you want to make your segment. It just means more that you have to turn off, but it also gives you a little extra in case you make a mistake or whatever. So let's say, for example, we come over to 3/8 of an inch on that side, and we'll do the same thing over here on the bottom piece, bottom part of this segment, this ring, and we'll come out over 3/8 there too. So what I can do then is if I draw down line there and a line there, that then is my segment. That's probably a little wide. I'll probably cut that back maybe 1/4 of an inch on either side, but that's a general idea. So then for the diameter, this diameter, the next column there, I would measure it from the center line out to the outside of this piece, and it would be about 1 15/16. So that would be my diameter, would be 1 15/16. Now that one was pretty straightforward. This one here would be a little more difficult because it's got this big swoop in it like that. So this one piece down here would be the limiting piece. So if I decided to go out 3/8 of an inch from there, I would mark 3/8 of an inch about right there. And then on this top piece, I would mark 3/8 of an inch in on this side, which would be right about there. So if I drew those lines in, that would be my segment right there, because I need it, because it curves like that. I need a lot of extra on the thing. So like I say, I think I got too much on the inside and outside, so I'll probably cut that back to 1/4 of an inch on either side. So anyway, that's the process. So let me finish drawing those in. I'll fix these two, and then I'll draw in the rest of them, and then I'll show you what I got after that. I finished laying out the rings on our vessel, and then on a couple of them I went and calculated the dimensions that we need. So I generally start numbering rings at the bottom. It doesn't really make any difference. So I got 6 here, and then 7 and 8 would be the holly one, and then 9, 10, 11 at the top, 12 counting the feature ring. What I did with this one, the number 4 ring, is I calculated a diameter, and really I did that as I just took my calipers and I measured from the center line out to the outside of the segment, and that gives me 1.835, and I just called it 1.83. However, that is only the radius. So that's where the mistake you can make is if you don't double that for the diameter. So if you use that number, you're going to wind up with a ring that's half the size as what you need. So 1.83 times 2 is 3.66. So if I take 3.66, you can see any of that, 3.66, and you have to trust me on this one, and multiply it times pi, which is 3.1416. That equals 11.49, and then I want to divide that by the number of segments. So divide it by the number of segments, which is 12, and that comes out to 0.958 or 0.96, which is almost an inch. They'll probably just make them an inch wide. So basically what you're doing is calculating the circumference of the circle of this ring, which is come out to 11 point whatever it was, and then dividing it by the number of segments, which is 12. So if you had 24 or 16 or 10, it'd be a different number. So then what I do then is I need to know the length of the board, or I like to put the length of the board I need. So it's basically it's about 11 whatever inches, and I usually add 6 inches to it just to make sure I have something for my fingers to hang on to when I'm cutting the segments. So that made that board length 17 inches. The segment width is actually this piece this way, so I just take my calipers and get it close to it, and it comes out to about 0.884 or 0.89 when I measured it last time. Thickness of the board, so that'll be actually the width of the board we need to cut the segments, and the thickness will be that piece, which it comes out to be about 0.8. So it comes out to just a little, about 0.8 or 0.77 or something like that. So right at the 0.8. So basically the board we're going to need is going to be about 0.89 inches wide, 17 inches long, and just over 3/4 of an inch thick. So if we do that and we cut that into 12 segments with a segment length of 0.96, we're going to get this ring right here. So the same thing at the top one. This is a little bit wider piece. So this one was 2.33 from the center line to the outside. Double that is 4.66. 4.66 times pi divided by the number of segments gives this segment length of 1.21. The length would be 20 inches. The width of the segment is here to here. It's 2.1 inches, and it's also 0.8. Actually, all of these are going to be 0.8 because it turned out that's what they all were, which is good. We want them all to be about the same anyway. So if we cut a board 20 inches long, a little over 2 inches wide, and a little over 3/4 of an inch thick, we'll have enough to make that ring right there. So that's the process. I'm going to go back and fill all these in, and then I'll come back and show you once I get it all done. Well, I'm sure it's probably difficult to see. I went ahead and filled in all the numbers on our chart here, using the same process as I did before, measuring the radius, getting the diameter, multiplying the diameter times pi, and dividing it by the number of segments, and then figuring out the length and adding 6 inches for some extra. And then I did measure this part this way, and that's the width of the segment, and then the thickness is up and down the top to bottom piece. So it's like I said, this is pretty much designed to be great for working on a spreadsheet. You could just put the numbers in and do a couple simple formulas and work it out, but I kind of like doing it this way. And you can do any shape you want in this process. You'd be able to come up with segments and rings that would allow you to accommodate whatever your design is. Like for example, this thing here, this big turn, we just have to have there's a lot of wood that we're going to have to remove, but we make it wide enough and thick enough, we can go ahead and make that turn. So we can turn that piece into it, and it'll look very nice. So that's how I do these. I do all of them the same way. So if you got any questions, please feel free to leave them in the comments. Well, that's how I laid out my project, my little Greek vase. I got a couple of other videos on YouTube. One shows how I made the Greek key, and another about putting the whole project together. So if you have a couple of minutes, I'd invite you to check those out. Like I said in the beginning, this is how I do these, lay out these projects. Is certainly not the right way or the wrong way. It just happens to be my way. So I hope you enjoyed it, maybe picked up a little bit of information. And if you haven't tried segmented turning, I'd encourage you to give it a try. It's a lot of fun. So if you have any questions, please leave them in the comments. Thanks for watching, and please check out my other videos here on YouTube.